Namaste friends, welcome back to this 10 solved problems, that is roots of polynomials using Python and Scilab. So in the previous video, the link is given below in the description. We have seen that how to solve, what is the philosophy behind the roots of polynomials, which are the various methods. We have not delved into the methods because we wanted to quickly jump into Python and Scilab. So now here are 10 problems where we will be using Python and Scilab for the solution. Problems predominantly I have taken from these two wonderful books, Numerical Methods for Engineers by Chapra and Cannell. This is the 7th edition. And another very good book by Khanna Publication, that is Numerical Methods in Engineering and Science, that is B.S. Grewal. It has very good compilation of university level problems in the book, large number of problems solved in both the books. So all credit for the problem statement goes to these two books. So we will be solving 10 problems here, and these are some of the problem statements that we have. Why it is saying other examples, because in the previous video I have already solved 2 problems here in that particular video. Now we are going to solve remaining 10 problems. Of course, when we are seeing, we will be seeing all 10 problems. After 3rd or 4th problem, you will say, "Bas karo sir, this is becoming repetitive," and that is the purpose precisely, that when you practice this more and more and more, you will realize that roots of equation is not such a difficult thing when it comes to Python and Scilab. So there are 2 types of problems that we have seen: the polynomials, which can be expressed as the coefficient array, like polynomial like this, or if there is a polynomial in trigonometric like sine, cos, tan, then that cannot be utilized. In this case, where the polynomial can be described in terms of a coefficient matrix, then we are going to use the roots function both in NumPy and also in the Scilab. But when we have a polynomial, or when we have an equation where there is a sine, cos, or some trigonometry being a part of the equation, then we will be using fsolve function in both Python and Scilab, and we will come into our own solution. Again, here the power of x is 4, so we are going to have 4 roots, either real or the complex roots. Okay, so here is the first problem. So the type of equation here, x raised to 4 minus x is equal to 10. This is the first problem here. X raised to 4 minus x is equal to 10, this one here. So it's a simple polynomial. We can obtain the coefficient array, and then we are going to use the roots function here for both Python and Scilab. This slide won't be there for other problems. This is just for the first problem we are seeing this. Okay, so when we are solving this using Python code, first we will importing the necessary libraries, import numpy as np, and then coefficient matrix, you provide the coefficient matrix as the array there, and now you invoke the roots function from np, that is numpy, and you print your roots. As this was the 4th order, then therefore we are seeing the 4 particular roots here available, right? The complex conjugates will become the roots in themselves. So the same problem now we are going to solve using Scilab. Same thing, very similar. Here we have the equation x raised to 4 minus x minus 10 is equal to 0. Then here is the coefficient matrix. Look at this, x raised to 3 is not there, x raised to 2 is not there, and x is there, and here looks like there is some mistake here. Anyway, we will go to the next problem now. The coefficient matrix is slightly mistaken here, so accordingly the problem is also solved in a wrong way. Please solve it right and tell me the answer, and do put your answers in the comment box. I want comment box to be filled with your answers, so that I am aware that you are watching through the video through. So at least take one problem, solve it, and put your answer in the comment box. We come to the second problem now, that is 3x is equal to cos x plus 1. Again, now here this problem has the cos term, so we will not be having a coefficient array here. So here what we are going to do, we are going to solve using fsolve. So we import numpy as np, we have to define the equation, in x, and then return 3x minus cos x plus 1. So this np cos x, because the cos, we are picking the cos function from np, that is numpy, therefore we are writing np dot cos, and then we need to provide the initial guess here. Initial guess is, it is actually, what is the initial guess? Initial guess is the gut feeling of your answer to you. where the solution domain you approximately feel where you are going to get your answer, and then we invoke the fsolve function. Root is equal to fsolve bracket, we invoke the equation and the initial guess, and we get the answer here. Okay, so now the same problem we are going to solve using Scilab, and Scilab also you first define the equation. Function is equal to y equation in x, so you define end function and then you invoke the fsolve, and you have the same answer 0.6071. This is x raised to 1, and therefore you have only one value of x as the root. So here you see previously 0.6071 and 0.6071. Of course, the same problem you are solving using Python or Scilab, so they will be giving the same answer. So sometimes when I am teaching this to the class, some students are making a mistake of importing, writing the code import numpy as np in Scilab. Now please make sure that you are solving most of the codes in Colab. Colab is a Python environment, and numpy is not defined for Scilab, right? So let's not do that kind of error. Now we come to the problem 3 now, and again the same problem 3 is this is the problem statement 3. Okay, so what is the 3? X cube plus 6x plus 20 is equal to 0. Find other roots while one root is 1 plus 3j. This is the problem 3, and now we come to problem 3 solution. Same, import the file, import numpy as np, define the coefficient matrix, it is definable there, invoke the roots function and get the answer. So we already knew one answer, that is 1 plus 3j. By common sense another answer was 1 minus 3j, the complex conjugate, and the other root is minus 2. Minus 2 plus 0j it says, but 0j means 0, so minus 2 is the answer. So roots are minus 2, 1 plus 3j, 1 minus 3j. These are the 3 roots, and this is how same we solve in Scilab. Again Scilab, simple it is, we define the coefficient matrix, we invoke the roots function, and we display the roots here. Minus 2, 1 plus 3j, 1 minus 3j. Scilab goes with I, Python goes with j, Colab goes with j. So I mean it's just one and the same thing. So now we are going to go to the example 4, and example 4 here is x raised to 7 minus 3x raised to 4 plus 2x cube minus 1 is equal to 0. Prove that it has at least 4 imaginary roots. So now let's come to example 4 there. This is definable in terms of a coefficient matrix, so we are going to use the roots function here. Import numpy as np. Using roots function is very, very simple, so that's why we default use roots, and if not then we use fsolve, right? So you define the coefficient matrix and then invoke the roots function, and we have here the roots of the equation. Because it was x raised to 7, you have the 7 roots, and as described there, 4 roots are imaginary minimum. Okay, right. Now same problem we solve using Scilab. So again define the coefficient matrix, invoke the roots function and display the roots, and these are the 7 roots. Of course the roots are the same roots which are there because we are solving the same problem. So these are the same roots using Python and Scilab. There is a purpose why we are solving same problem using Python and Scilab, so that you get used to the code structure, you get used to the syntax of Python, the syntax of Scilab, and it becomes just your second nature when you want to solve these problems using Python or Scilab. This course will go immensely useful as you start progressing in your second, third, fourth year of engineering or science, and when you come across the equation you will be itching to solve the equations. Those many equations we are going to solve, right? So this is example 4, and now let's go to example 5, and the example 5 is x cube minus 12x square plus 39x minus 28 is equal to 0, and prove that these roots being in the arithmetical progression. So now we again go, because it's coefficient define, we can define the coefficients, so we are defining the coefficients here, finding the again invoking the roots function, getting the roots, and now you have to prove how it is, in what proportion it is. Okay, the roots are, because it's third order, therefore roots are 7, 4 and 1. This was the 5th problem. So now we go to the 6th problem now. So these are the 6 to 10 other 5 problems. So now 6th problem, x raised to 5, so we'll have 5 roots. 7th problem we will be using fsolve. 8th problem also we will be using fsolve, and other 2 problems we will be using again the roots function in both Python and Scilab. Now won't be taking so much of time there. Example 6, the code is given here. Now you do the needful. Again, coefficient matrix, invoke roots function, display roots. Okay, same for coefficient matrix, roots function, display roots, and we have to import numpy as LP. So, and then the seventh one is again fsolve using. So you first, what you do, first you import numpy and then define a function. Here you define the equation. You need to give the initial guess, invoke the fsolve. Look at the syntax of fsolve. Look at, there are 2 things. Look at the syntax of function defining. Def equation x. Of course you can call equation as eq, whatever the way you want to define the equation. Eq you can say, equation you can say, you can give your name also. And then you need to provide the initial guess and then invoke this function. And look at the syntax of fsolve. Fsolve you give equation, you call it here equation, therefore you call it here equation. If you say eq, here it will be eq. Initial guess you can say ig also here is equal to 0. You can say eq comma ig, whatever the ig is you are defined, and then you will get the roots. Okay, the root in this case it is x raised to 1, so only one root. So this is the Python codes, and this is the 9th problem. Just the same, go ahead, import numpy, define coefficient matrix, invoke roots function, get the roots. Right? Same for Scilab, and this is the 10th one, and this is the last problem. So this is how we have seen these 10 problems, these 5 examples and these 5 examples, total 10 problems we have seen. And please, this is how you have to do it. Open Colab, open your Scilab environment, type these problems. This will not take more than 20 minutes, but you will be mastering this entirely very well and just getting ready for your next semester courses. So thank you very much for being here till last. Do solve at least one problem in the comment, and that shows me that yes, my students are going through till the last of the video. Do like this video and do subscribe, and ask your friends also to subscribe. Thanks a lot. Have a good day. Bye.